Hi class, Dr. Searcy here with the video lecture for the Chapter 6 Odd Numbered Problems. So let's begin by remembering that the title of the chapter is probability, and what we're doing in this chapter is we are basically answering this type of question. What's the probability that I'm going to find some particular x value under the curve, right? And just remember that we're using z-scores to help us figure that answer out. But to begin with, question number 1 is asking, what are the two requirements for a random sample? Now, I have not talked about this topic, at least in the textbook lecture. I kind of skipped over it. And my reason for doing so was I see this question as less having to do with statistics, right? My focus is to show you how to do like the equations at the back of the chapter and how to understand what those equations are saying. This question is more addressing the issue of when you have a population that you are interested in studying and you pull a sample of participants out of that population. This is talking about something that needs to be in place when you do that, right? And that's this idea of random sampling. I didn't really address it in the textbook lecture because I see this as more of something having to do with another class, the research methods class that you might be taking, the Psyc B5 right? That's where really this issue is addressed. But I'll go ahead and answer the question that they're posing here. Basically what they're saying is when you recruit a sample of participants, there are two things that have to be in place with those participants. First one is that each individual, right? So each individual person that you pull out of the population to be in your sample has equal chance of selection from the population, right? So say we're talking about that population of 20 or so thousand BC students. And we say that we're going to pull a sample out of that population. Well, this is just saying that every student in that population has to have a chance of being in the study, right? That's part of the requirements of the random sample. A second requirement that they're talking about is if you do have more than one individual selected, right? So you do pull repeated participants out to be in this sample. Usually sample sizes are about 30 people big. When you do that, probabilities must stay constant for all selections. This is kind of a hard concept to grasp, but basically what they're saying is you have 20,000 people that you are pulling a sample out of. As you pull each person out, then for the next person that you're going to select, that person doesn't have the same chance of getting selected as the previous person did, right? So they're saying because that's going to happen, you have to figure out a way so that each new participant does have that same chance that the previous participant that you selected had. So what do they do to solve this? Basically what they do is once they select a participant to be in the sample, they throw that participant, their information back into the population, right? So the population size hasn't changed. You haven't taken that person out. They're still back in there. So everyone else still has this equal chance of being chosen. Okay, so let's almost say in answer to this question, again, it's really a Psyc B5 research methods question and not something that we're really going to address too much in this class. So let's go ahead and move on to question number 3. More something that we will be addressing in this class. All right, so the question reads, around Halloween each year, the grocery store sells 3-pound bags of candy containing a mixture of 3 different mini bars. Right, so this bag's going to have some Snickers in it, it's going to have some Milky Ways in it, and it's going to have some Twix in it. Sounds like an awesome bag. But what they're saying is the bag is going to have an equal number of each candy in it. Right, so there will be an equal amount of Snickers, Milky Ways, and Twixes. Given that, what are the probabilities for each of the following of these three questions here? Okay, so the first question they're asking is, if you have this bag with an equal amount of Snickers, Milky Ways, and Twixes, what's the probability of randomly selecting a Milky Way bar, right? So you reach in, what's the chance that you're gonna pull a Milky Way out and not a Snickers or a Twix? In answer to this question, let's just remember what our formula for probabilities was from the textbook lecture. Basically, it was P equals some X value, right? Some random number that we're just kind of selecting, that divided by the total. I think the example that we used in the textbook lecture was like the playing cards. What's the probability I'm gonna pull a spade out of a deck of cards? We said there's 13 spades, right? So this would be 13. And then there's a total of 52 cards in the deck, so this would be 52. And I think ended up being like a fourth or 25% chance. Same idea here, except now, as far as your X and your total values, we're saying that we are talking about a 1 over a 3. So the 1 is this X, and why is it a 1? Because we're selecting a Milky Way bar. So we're selecting one of the 3 different kinds of candies. Why is the 3 there? Well, because that's the total. That's the total different types of candies that are in the bag. So with that, we say that we have 1 in 3 chance of pulling out a Milky Way, or a 33% chance of pulling it out. Okay, so then let's go ahead and move on to question B. This is saying randomly selecting either a Snickers or a Twix bar. Okay, so now we're reaching into the bag and we're asking what's the probability I'm either going to get a Snickers or I'm going to have a Twix in my hand. So that's now 2 out of the 3 candy bars that we're talking about, either the Snickers or the Twix. When that's the case, we're saying that there's a 67% chance of pulling either a Snickers or a Twix out. So then question C is saying, now is the probability of randomly selecting something other than a Twix bar, right? So something other than a Twix bar. Well, what is there other than a Twix bar? There is a Snickers bar and there's a Milky Way. So you're basically asking the same question that you were asking in question B. Except now you're saying that you're going to pull out either a Snickers or a Milky Way. Since we're saying that now we're potentially going to pull out one of 2, the 2 goes here, and we still have that 3 in our totals category. So it's still 67% that gets pulled out. Okay, so with that, we can go ahead and move on to the next question then. We're just getting this sense of understanding how probability is working and how we're going to be thinking about it in this chapter. But now we're going to apply it to thinking about it with z-scores. So here the question is, draw a vertical line through a normal distribution for each of the following z-score locations. Determine whether the tail is on the right side or the left side of the line and find the proportion in the tail. Okay, so let's just write underline tail there. And then I also want to underline proportion here. So they're basically asking for each z-score for us to do like these 3 different things. Draw the line through the normal distribution that represents where the z-score is in that distribution. So that's the first thing. Determine where the tail is in that distribution, and then find out what the proportion is. Okay, so let's look at it with question A, where we have a z-score of 1. The way I'm going to do this is, let's think about what we did in the order of operations from the textbook lecture, right? The first thing I think I said was, we want to sketch out what we're talking about. Sketch out the histogram or the curve that we're talking about. So I did that here. And what I see that we're talking about is we're looking for where z of 1 is on the curve. It's right here in this spot, right? Basically, I only drew 1 row. Basically, what we're saying here is We've also got that S row, right? We're saying that for S, that's the standard deviation. 0 is right under the mean, and 1 is 1 standard deviation out. But Z is right in line with where its numbers are right in line with where the standard deviation numbers are, right? So your Z of 1 is right on top of your standard deviation of 1. Okay, so that's our first thing that we've done. We know where 1 is in terms of the Z category on this curve. Now we're going to draw that vertical line through the normal distribution. Okay, so that's where the vertical line is, right there. Determine where the tail is on the right or the left side of the line. Here what they're saying is, by tail, they're saying where is the smaller chunk of the curve in relation to your Z-score. In this case, right, there's either this chunk of the curve or there's this chunk of the curve. This is the smaller chunk in the curve, therefore it is the tail of the curve. Where is that tail with regard to our Z-score? It is on the right side of the Z-score. So we're saying the tail is to the right. Just like that. Okay, so we've answered the second question. Now we have to go with and find the proportion in the tail. So I've already written that down. That proportion is right here, but how did I get that value? Remember what you have to do to find proportion of the tail is you have to go to your unit normal table in your textbook. You have to find the Z-score in question. Here it's 1, right? So when you find it, they're asking, well, what's the proportion in the tail? So for that row, Z of 1, you go to the C column where it says proportion in the tail, and you say that that's the proportion that you're looking for. That's the proportion that's in reference to that Z of 1. And so that's why, right, it was 0.1587. That's why I've written that down here. Now remember, the way that you want to interpret what that 0.1587 means is you're thinking, okay, that's 15.87%. But 15.87% is percent of what? Well, it's the percent of the entire curve. This tail section is 15.87% of the overall curve that you have here, right? So that's what you want to remember. Let's go ahead and move on to question B now and see how all this works. For question B, we're saying to begin with that we are looking for a Z-score of 0.50. Right, so the first thing that we're doing is we're trying to figure out where is that in the curve. It's about right here. I meant to line these two curves up. This one got a little over to the left, but what I tried to line them up to show was that 0.5 Z-score is going to be closer to the mean than is a Z-score of 1, right? Because that 0.5 is basically half of the distance from 0 to 1. So I'm hoping that you're seeing that, you're making that connection. But now we know where the Z of 0.5 is on the curve. We draw a vertical line on that spot, so that's a vertical line right there. Then we have to answer that other question, determine whether the tail is on the right side or the left side of the line. Again, what we're looking for is, of the whole entire curve, which is the smaller chunk on either side of the line that we've drawn. Is this the smaller chunk or is that the smaller chunk? Here we're saying that this is the smaller chunk. And the reason why is because if you look at the curve is split in half, this is a small, this is a chunk of half the curve. Whereas over here you have still the entire half all left to itself. So then this is the tail of this curve. So we're saying the tail is to the right. But now we have to answer the other question, find the proportion of the tail. Here I'm saying it's 0.3085. How did I get that? Well, I went to our unit normal table. I looked for that 0.50 and I found the tail amount. It's this amount in column C. And so that's why we're saying P equals 0.3085. But again, remember, we're thinking of that as this being the percent of the curve that represents the tail, or 30.85% of the curve is in this tail section. Okay, so keeping on moving, we'll now look at question C. Here now they're saying, oh, a z of negative 1.25, right? So this is the first time that we're looking at a negative number. Remember, a z that's negative is below the mean, or to the left of the mean, right? So that's where this z value is. So first thing I'm doing is drawing that vertical line that represents where the z is. Next thing I'm doing is looking to see whether the tail is on the right or the left side of the line. Right, so this is the line that we're talking about. When we're looking for the tail, what we're saying is we're looking for the smaller chunk of the curve, either on this side or this side. Obviously, this is the smaller chunk of the curve, so it's our tail. So we're saying the tail is to the left. Last thing we're doing for this curve is we're finding out what the proportion is in that tail right there. And we're doing it by going to our unit normal table. Remember that even though we're looking at a negative value here, we're still going to look for the positive version of that value in our table, right? So instead of looking at negative 1.25, sorry, number right? Yeah, negative 1.25. I'm going to look for the positive 1.25 and for the amount that's in the tail, and I'm seeing it's that 0.1056. So that's why I've written this down here. But again, we're thinking that it's 10.56% of the overall curve, or the tail is 10.56% of the curve. Okay, so now we're able to go to problem D. Again, it's a negative value. This time it's negative 0.40. Where would that be on the curve? Here we're saying it's about right here. I did a better job of stacking the two curves on top of each other. And I did that again to just kind of make sure that you're seeing of these two z values, negative 0.40 and negative 1.25, negative 0.40 is going to be closer to the mean because it's a smaller number relative to this one. Okay, but beyond that, first thing that we're doing is we're drawing that vertical line that represents where the z value is. Then we're looking to see where the tail is. Remember, it's the smaller chunk of the curve on either the right or the left of that z line. So we're saying that, oh, here's that smaller chunk here. So the tail is to the left again. Last thing we're doing is we're asking, well, what percent of the curve is that chunk? And the way that we're finding it out is we're going to that 0.40 in the unit normal table. See here I'm at 0.50, so I'm going to flip the page. And I'm going to look for 0.40. Okay, there it is right there. And there's our tail amount, that 0.3446. That's why I've written this down here. And so we're saying that tail section of the curve is 34.46% of the overall curve. Okay, so that's everything for problem number 5. Now we can go ahead and move on to problem number 7. And here the question is saying, find each of the following probabilities for a normal distribution. So let's just remember when they say the following probabilities. A probability is each one of these things. Where are we seeing the probability? We're seeing it in that letter P. That's a probability right there. What is the probability saying? Basically, it's saying, what is the probability that I'm going to find whatever's in the parentheses, right? So for problem A, it's saying, what's the probability that I'm going to find some z value that's greater than 1.25? Okay, so how do we go about answering that question? Remember, one first thing that we're doing is we are drawing the curve, and you're figuring out exactly what are we talking about here in terms of the area of the curve that we're looking for. So we're saying, what's the probability that I'm going to find a z greater than 1.25? I've found my 1.25 spot on the curve. I'm saying what's the probability I'm going to find something greater? Greater means on this side of the line, right? Something more than the 1.25. So we're saying what's the probability that I'm going to find some z value in this chunk, in this area. Okay, so since we know that we're looking now at the tail section of the curve, we can use that information to go look at this z at the unit normal table. It's 1.25, and our 1.25 is right here. So we're saying, okay, I'm looking for what's greater than the 1.25. That means I'm looking for what's in the tail of the curve. So therefore, I'm going to go to the C part of my columns. And for 1.25, I'm going to say that probability is 0.1056. So again, what does this mean? This means that there's a 10.56% chance that I'm going to find some z value greater than that 1.25, some z value that's in this section. Okay, so, and also remember, these rows stack on top of the standard deviation, right? So on the standard deviation, that will be where the 1.25 is as well. Okay, let's go ahead and move on to question B. There it's saying, what's the probability that I'm going to find a z value that's greater than negative 0.60? First off, thing that we ought to do is sketch that to make sure we understand what we're talking about. So here's our graph here. We're saying that we have that z value of negative 0.60, and we're wondering, what's my probability that I'm going to find something greater than that z? So we're wondering, what's the probability that I'm going to find something in this section of the curve? Now, at this point, one thing that you want to notice is that we're no longer talking about the tail section of a curve. Now, here, we're talking about most of a curve, the bulk of the curve, right? Half the hump and then some. When that's the case, when we're talking about most of the curve, right, and most of the curve being half plus some, then we're talking about wanting to know what's the probability that we're going to find something in the body of the curve. Okay, so when we're doing that, it's important to understand that, because when we go to look up the z value on the unit normal table to find the percent, right? So we're going to find that 60%. We're not worrying about the negative sign. We're just looking for the positive sign. We're going to say that instead of this time going to the tail to find a percent, we're going to go to the body to find our percent. Where is the body? It's the proportion that's in this column, column B. So the proportion that we're going to write down is this 0.7257. Right, and I've written that down here. Remember what we're saying here then is there is a 72.57% chance that I'm going to find some z value in this area, some z value that is greater than that negative 0.60. Okay, so let's go ahead and move on to question C then. Now the question is asking, what's the probability that I'm going to find a z value that is less than 0.70, right? So now we're looking off in the other direction, something that's less than the value that we're interested in. So to understand that, first, we'll draw our curve. I'm plotting where that z of 0.70 is. It's a positive value, and so it's going to be just a little bit above the mean, right? It's less than 1, but it's more than nothing, and it's more than a negative value, so it's going to be right here. Now remember, since we're saying what's the probability that I'm going to find a z less than 0.70, we're talking about finding a z in this direction of the z-score. And again, what you want to realize is that we're no longer talking about the tail again. This time we're talking about the body again. Why are we talking about the body? Because we're talking about half the curve plus a little extra. So that's the body. So when we do that, and we go to look up our z value at our unit normal table, we're looking for the z value of 0.70. We find it here, and because we're going to the body, we're going to go to the B column, and we're saying that we're going to say that 0.7580 is our proportion. Just to remind you, what that means is there is a 75.80 chance that we're going to find that z value somewhere in this section of the curve. Right, a little bit better of a 75 there. Okay, and then so now that lets us go ahead and move on to problem D. Here we're saying we want to know what's the probability that we're going to find a z that's less than negative 1.30. So we're going on our curve to below the mean at that 1.30 area. We're saying less than that amount. So what's in that area? With that, we go to our unit normal table. Look for 1.30. Seeing it here. We were saying, this time. Are we talking about the body or are we talking about the tail? Oh, I didn't even write it down. This time, because we're going back to talking about less than half of the curve, we're back to talking about the tail, right? So when I look up my unit normal table value, the z value, I'm going to say the percent or the proportion that we have here is 0.0968. So what percent of the curve is that? That is 9.68% of the curve, right? A small area. Okay, so let's go ahead and move on to question number 9 now. Here we're saying find each of the following probabilities for a normal distribution. Right, now they've written out the probabilities a little bit more, so that they're a little bit more complex. Let's take a look at the first one, the A, right? Just get a sense of what are they asking us here. Again, they're saying, what's the probability that I'm going to find whatever's in the parentheses? In this case, it's like two boundaries, boundary here and a boundary there. Basically, it's saying, what's the probability that I'm going to find a z where it is greater than, right, because that's where the part of the big mouth is, or well, let's say it this way. Where am I going to find a z where negative 0.80 is less than z, and z is less than 0.80? Okay, so to kind of understand that, let's think about it sketched out on the curve. And what would that look like? What would that sketch look like? Well, that's this sketch here, right? So it's saying, basically, what's the probability that I'm going to find a z in this space? What is this space? It is a space that the z, well, the negative 0.80 is less than the z that's in here, right? So you got your z's anywhere in here. That negative 0.80 is less than whatever z you find. But z is also less than this positive 8.0, right? So it's saying these are two boundaries within which we're asking that we might find a z-score. Okay, so how do we figure out what the probability is of finding a z between here and here? Well, what you do is you think of it in terms of like cutting off a chunk. We're going to start off by thinking about how much area is there from here all the way out, right? All the way out. What is that proportion? What is that probability? And what we're going to do is then we're going to find the other boundary, this boundary. And we're going to subtract this chunk from it. So basically, from here over to here, we're going to subtract that from it, and then that will be these boundaries that we're talking about. Okay, so how are we going to do that? First, what we're going to do is we're going to find the proportion on the unit number table that represents this spot and the proportion that represents this spot. What are those two proportions? Okay, so let's say for the positive 0.80 and looking back this way, we'd be looking for the body value, right? The major chunk of the curve. For 0.80, the body is 7.881. So that's why I've written that down here. Then from there, now we're going to look for the proportion that represents from here to here. Okay, and so the way that we're going to do that is now we're going to say, what is the proportion in this column that we haven't talked about yet between the mean and z? Okay, so now we're talking about this 2.2.